Direct and indirect proofs. A direct proof is an argument that employs deductive reasoning. You begin with a given information or premises that are assumed to be true, and from there, take logical steps toward establishing the conclusion by applying postulates, theorems, definitions, and etc. While an indirect proof, it involves assuming that the negation of the conclusion is true. If the succeeding deductive arguments lead to a contradiction, then the original statement is proven to be true. Otherwise, it is false. Okay, so let us take this conditional given here. If a conditional statement given. If 2x plus 5 equals negative 1, then x is equal to negative 3. So we're going to prove this conclusion to be true from this hypothesis. So by direct proof, we can use the two-column proof. That is the first column, which is statement, and the second column is the reason. So our first statement is 2x plus 5 is equal to negative 1. For what purpose? Our reason is that is in our given. Then from this given, we can simplify this by uh, adding or addition property of equality, and that is by adding negative 5 to each side of the equations. So if we're going to add negative 5 here, add negative 5 here, this will be simplified into 2x is equal to negative 6. Then, finally, if we're going to simplify this further, we want to isolate x. That is x is equal to negative 3 by applying the multiplication property of equality. And that is by multiplying 1 half to each side of the equation. 1 half times 2x, so this 2 will be eliminated, x is left. Negative 6 times 1 half, so half of negative 6 is negative 3. So notice that in our conclusion, we just proven that x is equal to negative 3. So therefore, we can conclude that this conditional statement given, if 2x plus 5 equals negative 1, then x is equal to negative 3 is true. The other way of proving is the indirect proof. So we will still use the two-column proof, but in this way, we're going to start with negating the given conclusion, which is x is equal to negative 3. So to negate that, our statement will be x is not negative 3. So that is our assumption, and that is by negating the given conclusion here. So 2x, our second statement is 2x plus 5 is equal to negative 1, and that is from our given. Then let us simplify this. It becomes 2x is equal to negative 6. How did it happen? We just applied the addition property of equality. If we will add negative 5 to both sides of the equation, so 2x is equal to negative 6 will be left. Then to simplify this further, we can multiply both sides by 1 half, so that 2 will be eliminated. 1 half times 2 is 1. 1 times x is x. Then negative 6 times 1 half, so that is negative 3. And we just apply the multiplication property of equality. So notice that statement 1 and 4 contradicts. So this is our statement 1, and this is our statement 4. Notice that in here, x is not negative 3, while in here, x is negative 3. So x cannot be both equal and unequal to negative 3 at the same time. Therefore, since they contradict, we can conclude that this given statement here, which is 2x plus 7 equals negative 1, then x is equal to negative 3, we can say that it is true. Okay, we have another given. If angle A and angle B are both congruent to angle C, then we can conclude that angle A, this angle, is congruent to angle B. So we're going to prove that by direct proof using the two-way column proof. So our first statement is angle A is congruent to angle C. We know that this angle here, the angle A, that is congruent to angle C. So that is from our given. So if angle A is congruent to angle C, it follows that the measure of angle A is equal to the measure of angle C. That is by the definition of the congruent angles. So this angle here, the angle B, that is also congruent to angle C. That is from our given. And it follows that the measure of this angle B is equal to the measure of this angle C. That is again by the definition of the congruent angles. Then we can say that the measure of angle A, this angle, is equal to the measure of angle B. And that is by transitive property of equality. Recall that in transitive property of equality, if A equals to B and B equals to C, we can say that A is equal to C. So, from here, since the measure of angle A is equal to the measure of angle B, we can also say that these two angles are congruent. That is by the definition of congruent angles. So, we can conclude that if this given statement, if angle A and angle B are both congruent to angle C, then angle A is congruent to angle B. So, this statement is true. So, by indirect proof, by using two-column proof again, we will start by negating the given conclusion. Angle A is congruent to angle B. Our first statement will be angle A is not congruent to angle B, and that is our assumption. That is by negating our given conclusion. So it follows that if angle A is not congruent to angle B, so it means the measure of angle A is not the same with the measure of angle B. And that angles that are not congruent do not have the same measure. So angle A is congruent to angle C. So again, that is from our given. So it follows that the measure of angle A is equal to the measure of angle C by the definition of congruent angles. Then angle B is congruent to angle C from our given. And it follows also that the measure of this angle B is equal to the measure of angle C by the definition of congruent angle. So we can also say that the measure of angle A, this angle, is equal to the measure of the other angle. That is by transitive property because these two angles are the same with measurement with this angle. So they are equal also. Now, notice that statement number 7 and statement number 2 contradict each other. So this is our statement number 2 and this is our statement number 7. The measure of angle A and B here are equal, while in here, not equal. So, the measure of two angles cannot be both equal and unequal at the same time. Therefore, since they contradicts, our statement is true. If angle A and angle B are both congruent to angle C, then angle A congruent to angle B is true.